Okay, so some examples from 10.4. Let's do the easy ones first. What? Yeah, how'd you get there?
9 times 9.
Okay, so let me think. How do I usually solve? Usually I try to get the x by itself, right? Okay, so what can I do to get the x by itself on this one? Square both sides? Square both sides? Okay, so I get square root of x squared is 81. Square root of x squared, is that x? There's some confusion with this thing, right? Okay, so we should probably have a rule. So let's remember how this kind of goes. So here are rules. We know the square root of x squared is absolute value x, right? You guys with me on that? Okay, when I take the square root of x and then square it, this is x. But what can't I fit in this? Yeah, negatives don't work in this side, right? So if I'm saying this is x, I'm really saying, well, it's x, but x has to be positive. That makes sense? So there's the other option, which is x, right? Which is x. But this works for all real numbers, right? You guys see that? So really what I'm doing is I'm saying, well, the square root of x squared is x, but it only takes positive things. It doesn't know what to do with negatives. Okay? So when I get to the end of this, right, here I squared this. I say, okay, this is x tentatively, right, which is 81. But I should make darn sure that the thing I get out of this fits back in the beginning. Yeah, 81's positive. That fits in. Check. Good. Cool. So when I get to the end of these, I should check my answers, make sure they fit in the original formula. It is possible for me to wind up with things that don't quite fit. Cool? Want to try another one? A little harder?
So we're only squaring one side.
No, we squared the 9. So we squared both sides.
Okay, so we're just solving.
Yeah, we're solving.
Solving
Yep.
and simplifying are two different.
Yeah, they're a little different. In this case, what my goal is, right? The goal for solving anything is to end up with x by itself. You guys see that? So here, my goal was to get, all right, I had root x. I want that to be an x. So I do something to get rid of the root. That's squaring. But I have to do it to both sides. So I get x is 81. And then I should check, did that fit? Cool? It's possible for these not to fit. Cool? All right, so let's try another one. Here's the square root of x minus 13 is negative 8. Okay, so again, my goal is to get x by itself, right? So how do I do that? Okay, so there's two options, right? There's either square everything first or move the 13 and then square stuff. You guys see that? Let's try the square stuff first approach just because I want you to see what happens. So if I square both sides, keep in mind everything I'm writing in red here is a bad idea. If I square both sides, I'm going to get this stuff squared is 64, right? Then what do I need to do to square this? FOIL. You guys see that? So if I FOIL this, I'm going to get a root x, right? That's the first. Then what? Minus
13 times
plus 169.
4.
What's the middle? The outsides and the insides are the same, and they're this times this, right? So I get negative 13 root x, and then another one, so I get minus 26 root x. So I get, right, this is 64, so I get x, right? Well, as long as x is positive, I get x. And then I get minus 26 root x plus 169 is 64. Is this better?
No. That looks a lot harder. Than what I did.
Yeah, this is nasty. We could actually do the quadratic formula and get the right thing out of here, but it's horrible. Because I have to think, instead of having x's, what I'm doing the quadratic formula to is root x's. It's not a big deal, actually. You just put a root x instead of an x in the quadratic formula. Okay, so this was badness. I recommend not this approach. We could force it, but it would be difficult and super confusing. So let's add 13 first. So if I add 13 to both sides, I get square root of x is 5. Then what? Yeah, then square both sides, right? Get x is 25. And then I just have to make sure it fits, right? So is the square root of 25 minus 13. See, square root of 25 is 5. Minus 13 is negative 8. Check. You guys cool with that? I really knew that was going to work as soon as I plugged x is 25 into the root x function and got something sensical out of it. You guys cool with that?
13 on both sides.
Yeah.
And then
So the goal is to get the root x by itself, and then you could square both sides. You guys want to see another option?
how are you doing?
So I had to square both sides, right, to get rid of the root x.
Yeah, but I thought.
So
Oh, if I'm putting that in the thing, I'm not doing anything for that, or I'm just squaring.
So here I'm solving, right? So I'm saying, okay, I've got root x, and that's 5.
Okay.
So root x is 5 times 5, right?
Oh, okay.
This is x, and this is 25.
Okay, I need
The two root things cancel, right? I get x by itself. When I take the square root of a number and square it, I get the number as long as the number was positive. You guys want to try slightly more complicated? Ramp it up a little. All right, so what if we had the square root of c plus 5 minus 3 is 6. Okay, so what's my goal?
Oh, okay.
I need to get the square root by itself so I can square both sides and get it out of there, right? So I got to add 3 to both sides. So that'll give me the square root of c plus 5 is 9. Then what don't you do that you kind of want to do? Yeah, definitely don't square root both sides because I need to square both sides. But what else shouldn't I do? You guys not see it? That's good.
Don't take the plus 5 out.
Yeah, some of you are going to want to subtract 5 to the other side. Why can't you?
Because one's the square root and the other one.
Yeah, because it's in the square root, right? So you can't pull it out. So once I'm here, once I've got the square root by itself, I square both sides. Then I've got a c plus 5, and that's 81. Then I subtract 5. I get c is 76. Okay, then what should I do with 76? Plug it in here, make sure that I can take the square root of it. So I get 76 plus 5 is 81. I can square root that, so I'm good. It's positive.
Wait, can we put it into?
Yeah, sure. So we're wondering, is the square root of 76 plus 5 minus 3, is that equal to 6, right? So 76 plus 5 is 81. Square root of 81 is 9. 9 minus 3 is 6. 6 is 6. I'm good. You guys see that? P.S. This kind of fast and dirty business is good for checking answers. It's not good for getting them. Okay, so don't do this. It's hard to grade. If you guys want full points on problems, the best way for me to give you the most partial credit you can get is if you tell me what you're doing at each stage. So I'm not drawing this out this way to kind of, well, I kind of am drawing it out this way to educate you, like let you catch up with what I'm doing. But the biggest thing is that I'm trying to get you a good habit. Should we try another one? Ramp it a little bit more.
27.
We'll get there. We'll get to horrible things. Let's try a different root for a minute. Okay, so here's something that's scarier, right? Why is this one inherently scarier? Because I can't square both sides. I have to.
Use the fourth power.
Yeah. Okay. So this step becomes.
Do we have to root it to the fourth, or the fourth that goes in the square at the top?
Yeah, I need to do fourth power both sides, right? Right, so my arrows are getting a little awkward because I don't have a nice word for fourth power. Should be hypercube both sides, but
Yeah.
that's more confusing than enlightening. Okay, so we're taking both sides, raising them to the fourth power, right? So I get 7v minus 3 is 3 to the fourth, right, which is 81. Okay, so then I add 3. So I get 7v is 84. Divide by 7, I get v is 12. What did I forget to do? Check it. So when do you have to check, when don't you? Not quite all the time. You can get away without it when the power is odd. Yeah, so when you're doing, if this was a cube root, the cube root and the cubing function actually undo each other. So I know that I'm not going to get anything funky out of that. It's when I've got even powers that there's this plus minus business that I have to deal with, because the even root functions don't actually undo the even power functions. They only give you the positive thing. Cool? So when there's even powers or roots, we have to be careful. When they're odd, we're good. Cool? You just do it. You don't have to check the odd ones. So is 4 even or odd? Even. Crud. I have to go check it. So I plug 12 in here. I get 7 times 12 is... You already did all the arithmetic for this, right? So don't be surprised. So 7 times 12 is 84, minus 3 is 81, which is something I can take the fourth root of. Okay, see, I don't even really need to check it's 3, I just want to make sure it fits. Cool? Really, I'm checking is the answer I got in the domain of the function. You guys see that? All right. Another one?
You see one that doesn't check
Maybe. Let's see if this one does it. I think it will. Okay. All right, so what do I do first? Okay, so options are what? Either square both sides, seems like a good idea to me, or panic. Can't take the 5 out, it's under the square root. The other option would be something like subtract the x to the other side, right? This like, oh, what if I get all the x's on the same side? Is that going to help me here? No, because yeah, after I square it, it will. But before I square it, getting the x to the other side ain't going to help me, so don't fall for that. So square both sides. You get x plus 5 is x squared.
And then you take your x over. What? Then you have a plus 5, you can take your x over on the other side, and you have a 5 equals x.
Okay. Let's try it. Subtle hint, might not be a great idea. Subtract x, get x squared minus x is 5, right? Then what are you going to do? Do the thing I want.
Well, I minus the x from the x squared and got x. It's 5.
Can't. X squared minus x isn't x, it's x squared minus x.
Yeah.
Divided by it would be, but
But not
minus
like-
is not.
Because they're not like terms.
Yeah, exactly. They're not like terms. So the thing I thought you were going to try to do is the 5 product rule, which is similar to the 0 product rule, but isn't true. You guys know what I mean? No?
No.
So the thing I thought you were going to do is this, where you factor.
Both sides.
Right? And then you say, okay, either x is 5 or x minus 1 is 5, right? But that only works for 0. It doesn't work for 5. You guys see that? Okay, so I think this was probably not the thing I wanted. What was the thing I wanted?
Do you want to put it in the quadratic formula way, like minus x squared?
Yeah, so let's see. If I move this stuff to that side, I'll get 0 is,
X squared minus x.
so what was the step there?
What?
What was the step there? What did I do to both sides?
Oh,
Multiply
add
by
it,
negative
add it.
one.
Yes, subtract it.
I subtracted x and 5. I applied minus x minus 5, right? Okay, so I got this. Now what do I do with this? Jam it in the quadratic formula.
You can't factor it?
I can try. Let's try for a second. So what do I need? I need multiplies to 5, adds to negative 1. What multiplies to 5? 1 and 5, nothing else. 1 and 5 going to add to negative 1.
No,
See, I can get 4 or minus 4.
right.
Not get, or 6, I guess, right? Minus 6, but I'm not getting 1 either way. So quadratic formula this is. All right. So if I cram this in the quadratic formula, I get x is, let's see, what's my A, B, and C? Okay, so
Oh. Maybe
So it's a plus b.
no.
No,
So I get minus b
plus or minus
plus or minus.
square root of b, which is x minus x squared.
If it's minus b,
Minus
it's
four,
or minus, there's
a.
Yeah, so I've got minus negative 1, right?
Right. But you gotta do it so that you know.
Plus or minus negative 1 squared minus 4 times.
1 times negative 5.
Okay. What? It's A. Okay, so I got this. And this is 1 plus or minus the square root of 21 over 2. This was a crappy example, Joe. I knew this too. I did this one in the other class. It's like, oh, you should change the 5 to a 6, and then it would be a better example. Welcome to the crappy example I made up and did twice. Sorry. Okay, so I got these two numbers, right? Okay, let's see. So, I should check them, right? Yeah, this is going to be kind of icky, right? Really, I just need to know if they fit in the square root thing, right? That'll be enough. Okay, so what does this square root thing take?
1 plus or minus square root of 21 over 2.
Okay, so I need to know if 1 is 1 plus square root of 21 over 2. Is that going to fit?
Are you trying to say that you're gonna put that in and add the 5?
Yeah, I just want to know if when I add 5 to this, can I take the square root? I'm not actually checking. I'm just saying, does this thing fit in this guy? Yeah, how do you know? Ah, forget the calculator. Yeah, if I plug this in there, I'm going to get this thing's positive, right? You guys see that? So this is positive, plus 5 is still positive. Can I take the square root of something positive? Yeah. So that one's going to fit. How about this guy? Well, this guy's... So what's square root of 21? That's going to be my hang up. Yeah, it's bigger than 0. It's between...
3 and 4? No, 2 and 3 and 4.
No. So what's 4 squared? 16. What's 5 squared? 25. 21's between 16 and 25, right? So this is between 4 and 5. So I might say, okay, this is bigger than 4 and smaller than 5, right? So 1 minus 4 or 5 is going to make it negative, right? So the worst it could be is negative 4. Then you divide by 2. That's still negative, but it's only negative 2-ish, right? Then I take that and I add 5 to it. Oh, crap, this one works. Right, because I get negative 2 plus 5 is positive something. So that one also works. You guys see that? This is kind of the number sense ballparking thing. Yeah, this is tricky shit. Straight up. Cool? All right. So that's